Okay, sorry about that, folks. It's a continuation of that second video. I had the packet problem written down incorrectly, okay, so I went through the whole thing and ended up obviously not being the same as that's in the packet. So just gonna do this last problem here and finish it up. Okay, so from your packet, okay, this was number 4 right here. All right, and we had our function f of x. By the way, look kind of nasty with the fractions here. Let's make this 1/3 x cubed minus 1/2 x squared minus 2x plus 1/3. That'll make it a lot easier to take a derivative here. That's the first thing we want to do. Okay, little f prime of x action. All right, 3 times a third is 1, raise x to the 1 less. 2 times a half is 1, raise x to the 1 less, minus 2. So really easy derivative here. It exists everywhere. It's polynomial. Let's set it equal to Mr. Pushy's IQ, zero. All right, we know it's x and x, easy factoring, plus and minus. 2 numbers multiply to 2, subtract to 1. So is that obviously 2 and 1. I want to generate a negative 1. Okay, so I get critical x values at x equals negative 1. Let's just extend that negative. And also x equals 2 right there. Okay, don't forget, I want to sketch this thing, so I need my crit points. It looks horrible, that negative 1. All right, so as far as crit points are concerned, we know we plug back into the OG function, the original function. Okay, and then 2 comma f of 2 here. Probably the most annoying part of this problem is plugging back into this fractional function. Not that it's something you really see all that often. Sometimes it's nasty plugging back in. Do the best you can with it, okay? We know mental math is, the weakest part of many people's math games. It's really more about the problem solving here. But plugging in negative 1, okay, cube of negative 1, you get a negative 1. Negative 1/3, square that negative 1, positive 1, so minus 1/2. Okay, minus 2 times negative 1, so really plus 2. Okay, plus 1/3. Works out nice here because negative 1/3, positive 1/3 cancel out. 2 minus a half is going to be, 1.5 or 3 halves. So negative 1 comma 3 halves. And then plug in that 2. Okay, 2 cubed is going to be 8. So we get what I did on Thanksgiving. 8/3 minus 2 squared over 2. So 4 over 2. So minus 2. Minus 2 times 2. So minus 4. And then plus 1/3. Negative 2 and negative 4 here are going to give us a negative 6. And 8/3 plus 1/3, that's 9/3, which is really 3. So negative 6 plus 3 is really going to give us our negative 3 right there. So those are our critical points. And that's where important things are happening, okay? And now, that's where I draw the line. I got to find a way to stomp on something, make it louder. Next video, there's going to be a lot of noise going on in here. But here's where I draw the line, the f prime line. Is it bounded? It is, okay? We can see from negative 2 to 3. Remember, put all critical x values on the f prime line. Put that negative 1 on there. Put that 2 on there. Make sure you do it in the correct order. Don't be putting 2 here and negative 1 here. Be very, very careful with something like that. Those are both places where f prime equals 0. All right, so f is going to have a little horizontal tangent line right there. That's important information. Plug back into f prime, right? The f prime line, maybe plug in like a negative 1.5 here. It's kind of annoying. You could plug in a negative 2 technically because there is an arrow at the end right here. I'm sure Chestnut would be telling me that if we were in class right now, but we're not, so sorry, Alex. But you could plug in the negative 2 because it's only because there's a restricted domain that there is a bound here. Technically, there's an arrow. But if you plug into the simplified version, plug in the negative 1.5. Negative 1.5 plus 1 is going to be negative. Negative 1.5 minus 2 is going to be negative. Negative times negative is a positive. The signs don't always switch. They will, for the first bunch of functions that we're dealing with, but eventually they won't when there are double roots involved and stuff like that. Plug in a zero, you get a positive times a negative, which is a negative. Maybe plug in a 2.5. 2.5 plus 1 is positive. 2.5 minus 2 is going to be positive. Positive times a positive gives us that positive there. So I know about increasing and decreasing. So I know f is going to be increasing. Let's go algebraic here. Let's say negative 2 less than x less than negative 1, but also 2 less than x less than 3. Always be used to algebraic notation, okay? It's not always interval notation and multiple choice, so be careful. As far as f decreasing, well, that's going to be from negative 1 less than x less than 2, because f prime is negative. When your slope is negative, you decrease. Extrema, we see that we have a relative max at x equals negative 1, relative min, rel min at x equals 2. At negative 2, remember, the function's going to start f and then immediately have a positive slope, right? So it's immediately going to increase. That's an endpoint min. Here, the function's going to be increasing. until it gets to x equals 3, and then it's going to stop. That's an endpoint max. Not the easiest thing to see, okay? But we could write that up. I'll say relative max. Let's do the maxes first, because now we have maxes and mins to compare to see about absolute extrema. So we know we got a relative max, rel max, and we know that occurs at -1, 3/2. Okay, we already have the y value we plugged into the original, but now we know we have an endpoint max. All right, so an endpoint max here is going to occur at 3, plug back into the original. It's an endpoint, any type of point. Always plug into the original. So 3, f of 3. So f of 3, plugging a 3 into this thing right here. So 3 cubed is 27, divided by 3 is 9. Minus 3 squared over 2, which is 9 over 2. And -2 times 3 is -6. Plus 1/3. It's definitely annoying here. 9 and a -6, put them together, +3. We'll go with a denominator of 6 here. Okay, multiply 9 halves by 3 top and bottom. Minus sign, you're going to get what? 27/6. Okay, and then multiply the 1/3 by 2 top and bottom. You're going to get plus 2/6. And then you might want to take this 3, give them a denominator of 6. So what is that? 18/6 minus 27/6 plus 2/6. I developed a lisp. I'll put the 18/6 together with the 2/6 first to give us 26th, and 26th minus 27/6 going to be -7/6. I don't want to have to say that again, but you can see he has the lower y value. This guy has the higher y value. We want to look for an absolute max, okay? And you can see since this guy's y value is higher, we know he's the absolute max. Obviously, when we graph him, he's going to be higher up, as far as this point right here. So there's our absolute max. So we did relative max, we did endpoint max right there. Let's get rocking with mins. So now relative min, rel min, we know occurs at the critical point 2, -3, -3, pardon me. Now we know that there's an endpoint min, and that one occurs at x equals -2. Got to plug -2 back into the original now to get -2, try it on your own, okay? Plug in, pause, and then I did answers previously. I ended up with a -1/3. Hopefully that's actually the correct answer, but something for you to try. Pause the video, try that out if you want to, and that's really technically the end of the problem, okay? But if you want to kind of get like a little sketch going on just to see what's happening, sketch. Okay, so a little sketcheroo. We already know that this thing has the domain from -2 up to 3. Okay, so a little something like that. Plot all those points first, okay? You know that there are critical points at -1, 3/2. So we'll say that's right here. And then another one at 2, -3. Okay, so we'll say that's like down here. Let's see if you can actually see what I'm writing. There we go. Okay, and then we have endpoints, right? Okay, we got an endpoint maximum that occurred at 3, -7/6. Okay, so 3, -7/6. I don't know, maybe like somewhere down here. And then we had another endpoint that was at -2, -1/3. So maybe around there. Okay, y-intercept, just for kicks and giggles. Okay, if you do f of 0 here, you get 1/3 back. So 0, 1/3, we'll say is right there. Look, we know there's going to be a local maximum. I called it a relative maximum right here at x equals -1. And we know that there's going to be a local min, or relative min, rel min, at x equals 2. Okay, we know the function increases from -2 to -1. So you can see when we draw my graph, I'm increasing from -2 to -1. Increasing as an n because I want to meet up with that local max right there. Once again, we'll talk about concavity tomorrow. Now this thing is going to decrease from -1 all the way to 2. Okay, so all the way from here to here. So -1, it's going to hit that y-intercept. At some point, it's going to turn from an n into a u. That's at an inflection point, something we'll talk about tomorrow, to meet up with this local min. And then we can see it's going to increase and stop right there. And you could see your points, okay? When I even talked about this endpoint min, I didn't actually identify the absolute min, so my apologies there, okay? You can see that this guy has a lower y value, okay? So we know that that's our absolute min. And look at the graph. You can see that it's actually the lowest point of the graph, 2, -3. And you can see the highest point of the graph is -1, 3/2. So if you have the picture absolute extrema should be pretty easy to understand. So remember, big problems here. Okay, hopefully these videos get a little bit shorter as we get going. Let me know if you feel like the work is too intense for you, too much. You don't know what the heck I'm talking about. But remember, as far as today, we just really did a review of yesterday, did some more problems, but talked about endpoint extrema. Not the easiest thing to identify just by looking at the line. Okay, so do the best you can with that. Make sure you practice your homework, and we'll see y'all back here tomorrow. Stay healthy, stay safe. Adios.